Okay, so hello and welcome to lesson 4 of the theme 5 online geography resources. The last couple of lessons we focused on low pressure weather systems where the air is rising air makes cloud brings rain. We've been looking at the low pressure weather system depressions. Now, like I said, there's only two types of weather system. It's either low pressure, like we've been looking at, or it's high pressure. And that's what we're going to move on to today. High pressure weather systems are called anticyclones. So we're going to identify the key features of an anticyclone. We're going to compare and contrast how winter and summer anticyclones affect the UK, because they do happen in both seasons. And we'll then look at weather symbols on weather charts and look at how we can interpret them and read them to understand what weather is going on a weather map. So pause the video here a moment and put down today's main title. Okay, so first off, let's look at the main features of an anticyclone. You'll be glad to hear anticyclones are far more straightforward than depressions. There are no fronts, there is no cloud, there's no spiraling, rising air and all that kind of business. Far more straightforward. Okay, the main features are basically the opposite of everything that a depression is. So if you were given a satellite image like this, anywhere that there is cloud, air is rising. That is low pressure, because remember, only rising air makes cloud. The UK is experiencing an anticyclone here. There's no cloud there. The air is sinking. No cloud can form. So a weather map of an anticyclone looks like this. Now, if you remember, in a depression, the winds spiraled anti-clockwise. If you look here, they spiral clockwise. The isobars that show the pressure and the wind speed, if you look, the numbers increase towards the centre. It's high pressure at the centre of an anticyclone, whereas in a depression it was low pressure at the centre. And the isobars are quite far apart. There is wind sometimes in an anticyclone, but the speed is far, far, far lower. The conditions are much more settled than in a depression. So the isobars are farther apart. So in a depression, you've got anti-clockwise, high winds, rising air, cloud and rain. In an anticyclone, you've got sinking air, high pressure, no clouds, no rain. Okay, so your winds are moving clockwise. The air is sinking to give high pressure. Remember, I tried to get you to imagine as if the wind has as if the air has a weight to it now. So as that air is sinking, it presses down on the Earth's surface, and that's why we call it a high pressure system. Pressure is highest at the centre of an anticyclone. The isobars are further apart, so the winds are far more gentle than in a depression. It moves much more slowly. It tends to bring settled weather for quite a number of days, and these weather systems can occur in the winter, and when they do, they bring those really crisp, sunny winter days with freezing cold temperatures, and when they happen in the summer, they bring those boiling hot, cloudless heat waves that, if they go on for long enough, it can create drought conditions. Now, you've got this image on your handout, so if you're able to print it, cut it out and stick it in and write down this bullet point list next to it. If not, just leave a little bit of space in the top corner of the page underneath where you've written the title and write down this bullet point list of key features of an anticyclone. So pause the video here a moment and do that. Okay, so the conditions that are brought when an anticyclone happens in the summer versus when it happens in the winter. A summer anticyclone we all long for these weather systems during the summer months because they bring that really sunny, clear sky, warm weather, which is great. Many advantages come with this kind of weather system in the summer. It boosts the tourist economy because everyone goes to the beaches, everyone books staycations, they spend money in local restaurants, cafes, ice cream parlours. It's ideal for the British tourist economy. But if it gets a bit too hot for a bit too long, it can cause problems. Depending on your age, you can fall into a vulnerable group. The very young and the very old will struggle sometimes to regulate their body temperature. And very small children and the very elderly can find that they overheat. And actually that can be very, very dangerous and make you very, very sick. You can get heat stroke, and actually heat stroke can kill you. In addition to that, if you get drought conditions going on for too long, then farmers' crops are going to fail. And that means that they lose their income. And if you remember, we were using terms quality of life and standard of living. Quality of life is how happy and healthy you are. Your standard of living is how much money you have and the possessions that you're able to afford and the luxuries that you're able to afford. So in the case of vulnerable groups, if you're getting very sick with heat stroke and things like that, you're going to have a lower quality of life. You're not very happy and healthy. In the case of farmers losing their crops, that's going to mean that they lose their income. That's going to decrease their standard of living. So it's a bit of a double-edged sword, anticyclones in the summer. It depends how long they go on for and how high the temperatures can get. When you get an anticyclone in the winter, it brings those really crispy, icy, freezing conditions, which on the one hand, in Britain, perhaps in some mountainous regions, that could mean we might be able to start promoting maybe some winter sports, a bit of winter tourist industry, a bit of ski industry, which would boost the tourism economy through the winter as well, which would be ideal. But there are quite a few downsides that come with winter anticyclones. Frost can kill crops as well, so that would have a similar effect with farmers losing their income. But the roads become very, very icy and very, very dangerous, as do the pavements. So you get more traffic accidents, you get more people slipping and breaking wrists, breaking elbows, and that's going to mean that you've got more people going into hospital, and that's going to put pressure on the healthcare system. You've also got the problem of the elderly really do feel the cold. So you get quite a lot of elderly people being admitted to hospital in the winter months with pneumonia and conditions like that. So again, lower quality of life for the individuals, but also pressure on the healthcare system. Plus, I don't know if any of you experience this with your grandparents, but the elderly tend to have the heating whacked right up 24/7 through the winter. It's absolutely boiling in their homes because they do feel the cold more. Now, on the one hand, that's going to mean that energy companies are going to be raking it in. Everyone's central heating is working overtime through the winter. And in the current climate that we're in with regards to climate change, energy companies could use that increased income to research renewable energy alternatives. So that money could go towards reducing climate change in the long run if we look into more renewable energies. But it does mean on an individual basis that your bills are going to go up. Your heating bill is going to be through the roof. And if you're elderly and you're on a pension, you don't have much money coming in. So that means that because your heating bills go through the roof, you have less disposable income. You haven't got as much spare cash, and that could lower your standard of living. So there's pros and cons to anticyclones when they happen in the winter and when they happen in the summer. And that's what we're going to do next, is put this subheading, how does a winter and summer anticyclone affect Britain? Put down the table like it is here. In fact, to be honest, you could put an additional category over here of just general conditions. So you then have like hot, dry, heat wave, and then icy, cold. Yeah, you could do that if you wanted to. Put in an extra row up here, general conditions, but definitely have the advantages and disadvantages down there. Now, I've put a couple in as an example of the level of detail that I want you to include. And the way that you're going to fill this table in is using two things. Number one, rewind and re-listen to what I've just said, talking about those prompt images on the previous slide. Number two, in the folder for this lesson, there's also a short video clip that runs through with some images and some text over the top of the images, what the upsides and downsides are when an anticyclone happens in the summer and when it happens in the winter. Okay, so put this subheading, Draw out this table with plenty of room to write in it. I want at least 2 or 3 bullet points in each box. As you can see, note-taking format is fine with little dashes or equal signs. So I would suggest, to be on the safe side, to be honest, especially if you're going to include the general conditions extra row there, you might want to just take a whole page 10 sideways to be on the safe side. And then rewind and re-listen to the explanation on the previous slide. Watch the video in the lesson folder and fill this table in as much detail as you can. Pause the video here a moment and go ahead and do that. Okay, so what we're going to move on to next is, hopefully you've seen that anticyclones are far more straightforward than depressions. They just bring clear skies, settled conditions, lower wind speeds. It's very common in an exam that you'll be given a weather map and it'll be a satellite image, and it will ask you what weather system is affecting the area shown in the satellite image above. Straight away, if you can see cloud on there, it's a depression. If there is no cloud, it's an anticyclone. And then the follow-up questions will be about the conditions that that area is experiencing. So what they'll give you is a breakdown of weather symbols. You do not need to learn this off by heart. They will always give it to you in an exam, okay? And on the satellite image, there'll be cloud or no cloud, and dotted over the satellite image in a few different places probably will be a weather chart, okay, that looks like this. That is a weather chart here. It's actually far more simple to read than it looks. You start with the circle, okay? Now the circle represents the sky. When you look up, how much of the sky is covered in cloud? Now it's split into eighths. We call them octas because it's in eighths. So you just colour the circle to represent roughly the proportion of the sky that's covered in cloud. Okay? So that's what the circle's all about. There'll then be some kind of symbol. All right? And it tells you what the actual weather conditions are. Is it raining? Is it sunny? Is it icy? Is it sleet or snow or mist or whatever? Okay? There's not actually a sun symbol on this one. On this example, you've all seen weather reports on TV. It's just literally a little black and white sun. But yeah, temperature, there'll literally just be a number. Okay, sometimes it'll have a minus before it. If it's low temperatures, there'll literally just be a number around the edge of the circle. Now then, the wind direction and wind speed. The main stick represents the wind direction. Now, what you've got to be careful of, the wind is named after the direction from which it prevails. That's a posh way of saying the direction that it's come from. So although it appears that this stick is pointing that way, so you'd think down here is southwest. Oh, it's a southwesterly wind. No, okay? It's actually the direction that it's come from and is going to. All right, so this is actually a northeasterly wind. Does that make sense? If that stick was sticking out the top here, it's come from the south through. It's a southerly wind. If it was sticking out the side here, that's a westerly wind. If it was sticking out the bottom here, that's a northwesterly wind. Okay, that's quite often the trickiest bit to get. And then these little things on the end of the stick are called feathers. Each half a feather represents 5 knots. So a full feather is 10 knots. A full and a half is 15. 2 fulls is 20. Okay, so 30 knots would be 3 full feathers. 25 knots would be 2.5 feathers. Okay, up to, that principle applies up to 50 knots or more. All right, so for example, if this weather chart was on the map, it might ask you what are the conditions at location B, or what are the conditions over Swansea on the map, and it will have a little weather chart like this over that area. All you need to do is look at the key that you've been given, because they will give you this, and interpret it. So the conditions in this case, 2 octas of cloud cover, The wind is a southwesterly wind. Remember, it's come from the southwest and sticking out this way. So the wind direction is southwesterly at a speed of 10 knots. That looks like a full feather to me. Okay. And the temperature is 4 degrees C, and the weather is drizzle. Okay. Oh, I've gone for 5 knots, but you'd be able to tell much better in an actual exam whether it's a full feather or a half feather. Okay. What we're going to do next, I would like you to put that subheading down. If you're able to print it out and stick it in, great, stick down this key. If not, don't worry, just refer back to this slide when you need to for the next task. And I'd like you to draw out and label, like I have, this example of a weather chart. Okay, so basically make your half a page look exactly like my slide here. Pause the video there a moment and do that, please. Okay, so what we're going to do is apply that understanding. I'm going to give you some weather conditions and you're going to draw your own weather chart for those conditions. So here are your conditions. Draw a weather chart for a day with the conditions 23 degrees centigrade, 2 octaves of cloud cover, a westerly wind direction of 2 knots of speed. Knots is just the unit we measure wind speed in. And sunny conditions. Now remember I said on your example of a weather symbols chart, there isn't actually a sun symbol, but it's literally just a black sun. Okay, little mini sunshine. So write out those conditions and draw what you think is the correct weather chart to represent those conditions. Pause the video here and do that, please. All right, so if you have drawn anything along these lines, you're on the right track. Okay. Oh, that should say 23. Okay, 23 degrees C. 2 octaves. Remember it's eighths, so 3 octaves would be that much, 4 octaves would be that much, 5 octaves would be that much, 6 and 7, and the whole thing coloured for 8. It's a westerly wind, so it's come from the west and it's going that way. 2 knots. You only start drawing feathers when you get to 5 knots. Okay, so 1 to 2 knots is no feather. Sunny conditions. Now I've copied and pasted obviously a colour version off the internet, but just a little black sun symbol is fine. That number 4 should say 23, remember. All right, classic Gleason mistake. Right, I'd like you to do that twice more, please, just to reinforce the understanding that you've picked up. So write out the conditions for this day, draw a weather chart, write out the conditions for this day, draw a weather chart. Okay, you will see octaves spelt with a K or a C interchangeably sometimes in different resources or different online sites, weather sites, but just just to be aware of that. Give it a try. Pause the video here and give it a go. Okay, that is the end of lesson 4 on anticyclones and weather symbols. Hopefully you found today reasonably straightforward. Anticyclones, like I said, are far easier to get your head around than depressions. There's no fronts, there's no rain, there's no different clouds, none of that business. It's far more straightforward and brings much more settled, sunny conditions. Next lesson, what we're going to look at is when an anticyclone creates drought conditions, how can that affect an area? We're going to move to a little bit more of a global scale and look at a region called the Sahel. This is a band of almost desert that lies between the Sahara Desert in northern Africa and the African savanna grassland just to the south. And it has very dry conditions. It's affected by anticyclones pretty much constantly, so it gets very little to no rain whatsoever. And we're going to look at what the impact of those drought conditions are, what caused them in the first place, how they affect people, the environment and the economy, and how ultimately we could potentially try to reduce those impacts sustainably, because people are starving. It's incredibly poverty-stricken across the countries throughout the Sahel region. So we'll take our understanding of anticyclones and how they create heat wave and drought, dry weather, and apply it to this Sahel region in Northern Africa. So again, as usual, any questions or queries, please do drop me an email and I will get back to you within 24 to 48 hours maximum.